Before we start this episode, a large thank you to Zanji, Benjamin, Pez, Nick, Chase, Josh, Nicola, Craig, Ias, Sam, and Napasorn for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Slim Shaggy for their immense support to the channel on Patreon. You are greatly appreciated, my friend. Thank you. Hello, everybody. Today we're going to make it so our character is able to move. And we're going to sync that movement via multiplayer. So let's start by opening up our player locomotion manager and the player input manager. We're going to do some work on both of these scripts today. So first we need to take our movement input here, the vector2, and we need to give it two separate values, one for the y and one for the x. So let's make a serializable field, a variable of type float. Let's call this vertical input. And then likewise, do the same for horizontal input. So just again, serialize the field so you can see it in the inspector if you just want to check out your values while you're running the game. And then make the variable type float and make one for vertical and horizontal input. Now we need to take the movement input, the vector2, and split it into these two values, or rather, assign these values the x and y components of the movement input. So let's make a new function, private void handle movement input. And let's simply say vertical input is equal to our movement input, as in our vector2, dot y. And our horizontal input is equal to our movement input dot x. And just like that, now we have the values of our joystick up and down or left and right. So we need to combine these to make our total movement. And we're going to do that by basically making a third float called move amount. And this will basically take the total of our up and down and left and right direction and give us a total movement amount. Now we're going to use a thing here called mathf clamp 01 to make sure the move amount is always a value between 0 and 1. And then we're going to use mathf.abs for both our vertical and horizontal input, and we're going to add them together. Abs just means absolute value, more on that in a second. So we're going to say mathf.clamp01, and then open up some brackets, and we're going to say mathf.abs vertical input plus mathf.abs horizontal input. So what is abs, or absolute value? It basically means that the value is, in this circumstance, always going to be positive. It just makes it so it removes the sign of the value and just gives the absolute number. And we want that because we are adding these together, and we don't want, say, a left movement, which will be a negative on the x value, to add with a positive y movement to make a lower number. So we just always want the total number of the movement, regardless of the sign. So if you're moving left, you are moving. If you're moving right, you are moving. We don't want the negative one or positive one. We just want the 1. Now we have our move amount, which is our total movement with the up and down and left and right movement combined. Now we want to clamp it. And you don't have to do this. This part is optional, but I like it. It makes the movement feel a lot better to me. So we're going to say if the movement amount is less than or equal to 0.5 and greater than 0, then we always want it to be 0.5, which will be our walking indicator, 0.5. Else, if the movement is greater than 0.5 and the movement amount is less than or equal to 1, then we want the movement amount to be 1. So basically the movement amount is now always going to be 0, 0.5, or 1. Likewise, this will equate to you being idle, walking, or running. And in the future, you'll be able to sprint by using a button, which again will change your, not your movement amount, but your movement speed based on that input. But I'm getting ahead of myself. So you don't need to clamp it, as I was saying, but I like doing it. I think it makes the movement feel a lot better. And I'm relatively sure that Dark Souls and Elden Ring both do this. And it does, to me, make it feel a lot more clean. Okay, so I'm going to put a comment here saying this is optional. If you don't want this, you can totally get rid of it. But I suggest you keep it if you're going for that Souls controller feel. Next, let's make an update function and call our handle movement input here. So this is updated every single frame we are using the joystick. All right, so now back on the player locomotion manager, I'm going to take a sip of tea. Okay, so the first thing we want to do is make a public float for our vertical movement. And then one for our horizontal movement. This is going to be a lot more important when we add our animation blend tree, but bear with me for now because we are going to use it in this video too. And then lastly, our public float for our movement amount. So you can make a comment here if you want that these values are just going to be taken from the input manager, because I just like having them here as well. But you don't need to do that. Just for now, we're going to press on. I'm not going to put a comment there personally, but you can if you want. So they are going to be the same. Then right above the newly created floats, I'm going to make a variable for the player manager. And on awake, I'm going to say Well, first we need to make this derived from our character locomotion manager so we get its base class. And let's go there and check and see if we have an awake, and we don't. So let's make a protected virtual void awake so we can access it from the player locomotion manager. Because in the future, we will have things that are shared by all locomotion managers, player and AI. So we're going to put that logic here. And let's not put anything on the awake for now, but let's go back here now and override that awake and say base awake. So we call the logic on there that will be there in the future, and we write our own. So we're going to say player equals get component player manager. Okay, so now that that's done, we can use the player now to reference what we're going to do in the future to move this character using a character controller component. But right now we don't need it, so let's press on until we get to that point. Let's make a private vector 3 for our movement direction. And this is just going to be the direction that the character is going to move. It's going to be based on your camera's look direction and your input. So let's make a private void for handle grounded movement. And as the name suggests, this will be how you move your character when you're walking or running around on the ground. So let's start by saying our movement direction is equal to, now you could say in some cases camera.main, but we don't want to do that because we want the direction of a different object. You see, our camera is going to rest under a pivot game object, and that pivot game object is going to rest under a player camera game object. We want that game object, the parent of all. So let's make a script called the player camera. And let's open that up, and let's just go in here and erase the start and update functionality. We're going to make our singleton by saying public static player camera instance. And then we're going to make an awake method, and we're going to say if the instance equals null, the instance is equal to this. Otherwise, destroy this game object as is per usual. Now, we're only going to have one of these in the scene at a time, and the camera will go to the local player. So let's save this. And then let's go back over here and handle grounded movement. And we're going to say move direction equals player camera.instance.transform.forward times our vertical movement. And then we can say move direction equals player camera.instance.transform.right times our horizontal movement. And that's movement direction equals movement direction plus player camera.instance.transform.right times horizontal movement. And I'm going to take a sip of tea. Okay, so now right under that, we're going to say move direction dot normalize, and then movement direction dot y is equal to 0 because we don't want to move up and down. We only want to move forward, backwards, left, and right. And we make a comment here saying our movement direction is based on our camera's perspective and our inputs. Okay, so now we need to again check for our movement amount. And since we haven't called it here yet from our input manager, I'm just going to reference it directly from the input manager. If you're wondering if there's any special reason why I'm doing that, there is not currently. I don't want to explain too much. I'm trying to do this in segments because there's a lot to the total system, but right now you don't need to worry about the movement amount, vertical movement, and horizontal movement variables on this script. So we can actually reference the singleton of our movement amount, but first we need to make it public on our player input manager. And we come back here now on the player locomotion manager and say if player input manager dot instance dot move amount is greater than 0.5f. We want to open up some brackets here and write some logic. What do we want to do in here? Well, we know that our move is at a running speed, so we want to move our player at a running speed. Else if, then we're going to say, we can copy and paste this here and just say if it's less than or equal to 0.5f, then we know we are at a walking speed. Okay. And basically the movement input will be 0 if we're not moving our joystick at all, and then none of that logic will run. So up top here, let's make a serializable field for the float walking speed and the running speed. And I'm just going to choose two random numbers here, not going to think too much about it. You can adjust these as you see fit. It's best to look at your animations when we add those in and see how they look with your running and walking animations. So I'm going to say 2 for the walking speed, and I'm going to say 5 for the running speed. All right, so now back down here, we need a way to move our character. So let's go to the character manager base class, and we're going to add something to it. But first, actually, let's go to our player prefab added here first. It's called a character controller component. So add this to your player prefab. And then you want to drag your player in the scene so you can see what it looks like on them. Make sure you tick this little symbol in the top right if you can't see anything around your player. This is check on gizmos, and you should see a collider of sorts when you click this like that. So you can see here, there is a capsule collider, and this is actually brought in by the character controller. So adjust the radius and the height of it until it's about fitting where your player's body is. And if it's too high, you're going to know because your player will kind of be not at ground level perfectly. And the same goes if it's too low. So these values will differ depending on what model you're using. After you've done that, copy the component and then go to your prefab, right click and paste component values. And that will put the same values that you have in the scene on the player prefab. So now that's done, we can reference this component via script. So on the character manager, let's make a protected character controller component. Call it character controller. We're making on the character manager because both the AI and the player will have one of these. And then down here on the awake, we can say character controller equals get component character controller. And now the player will get it too because it's on the base class. So we can say player dot, and we actually make that public, not protected, my bad, because we're accessing it from another class. So let's make this public, and then we can say player dot character controller, and we can use this to move the character. Now, just to be clear on why I can access this, if we go back to the character manager base class, you can see here we have this character controller component on the character manager. And we know that the player manager derives from the character manager. And because this variable is a public or protected variable, we can use this on the player manager as well. So we say player as in player manager dot character controller dot move direction times our, and this is our running motion, so it will be running speed. Now down here, we'd also need to say at the end of this, oh, I need to correct this, sorry, this is supposed to be less or equal to 0.5. We also need to say at the end of this times time dot delta time. Okay, so then we copy and paste this down here and replace running speed with walking speed. Okay, that's basically it for the movement right now. So we need to call this now under handle all movement. We're going to say handle grounded movement. Make sure you call it here because remember this function is called on every frame on an update method. So let's call our movement right here. And now let's save that. Let's go over to the player camera. What we want to do is make a start method, and let's just say do not destroy on load and pass this game object. So when we change to the world scene, our camera survives the change. All right, so now I'm going to go and create an empty game object for our camera. I'm going to call player camera, going to reset the transform so it's at 0, and I'm just going to simply right now drag my camera object in there. I'm not going to make the pivot right now because we're not doing the camera video. And let's make a prefab of that and drag it down there. And that's all we need to do. Oh, and we need to add our player camera script to the prefab. Save the prefab again once that's been added to it. Okay, so over here now on our player input manager, or sorry, our player locomotion manager again, let's make a private void for get vertical and horizontal movement or inputs. So we're just going to, again, fetch the same values exactly that are on the input manager, but put them here. So I'm going to say vertical movement is equal to player input manager dot instance dot, and then we would say vertical or horizontal inputs. Let's make these public. And again, you don't need to specifically do this. You can just reference them from the input manager. But for what we're going to do in the future, I like having them over here instead of having to call them from over on the input manager. So I'm going to say a vertical movement is equal to player input manager dot instance dot vertical input, and then extending with horizontal. And you can do the same thing for movement amount if you want. And then in the future, I'm going to make a comment here for clamp the movements when we do animations. Again, this is not too important right now, but it will be more important in the future. So I'm going to say get vertical and horizontal inputs, and I'm going to leave it at that. So right now they're not being used for anything, but they will be in the future. All right, so now if I go into the game here now and press start and new game, you can see I'm actually able to move around. So that is working as intended. But if I were to say open a new clone project, which I'm going to do right now, and if I were to drag the window over and try to move around, so I'm going to press play again here now and go into, this is my main project. I'm going to press start, and then I'm going to click new game, and I'm going to move the character around. All right, so that's fine. Now let's drag in the multiplayer window, and let's see what happens if we try to move that character around. So here's my window. I'm going to press play. I'm going to let that build. I think it has to compile. There we go. Press start, new game. I'm going to connect, and you can see it moving both at the same time because it's registering both inputs for both windows. We'll fix that in this video too. So start game as client. I go into the game here. Now, if I were to move my joystick, you're going to see them both move. That's just because, again, the input managers are firing on both projects, but that's not actually multiplayer movement. I'll show you because if we go into scene view here now, and I move the character via this transform, you can see here he's up higher than me, but here he's below me, or he's in front of me, and here he's behind me. So here's an example again. You can see I'll actually make both windows the same size. There's no movement happening here. It's not syncing, okay? So we need to sync the movement so that if you move on one end, the person on the network receives your movement and updates your character model on their screen, respectively. Okay, so let's create a new C# script. I'm going to call this Character Network Manager. And this is going to handle all things network related in the future, all calls and data. So I'm going to make my namespace SG as is per tradition. And I am going to start by saying using unity.netcode. And then I'm going to change this from a mono behavior to a network behavior. And this is still the same as usual. It just gets a whole bunch of things that our network can use. So I'm going to make a network variable. A network variable is a variable that will basically update and change for everybody if the owner changes it. So I'm going to start by saying header position, and let's make a network variable for our position. So we're going to say public network variable, and then we're going to make it of type vector3, and then we're going to call this our network position. And then we're going to say it equals new. And we're going to say network variable vector3. And then we're going to say vector3.0 is its starting value. And then we're going to make it so everybody can read it by saying network variable permission repermissions.everyone. And then only the owner of this can write it. So we're going to say network variable permissions.owner. What does that mean? It means if you own this character object, you are able to edit this position. And if you don't, you can only read what it is. So you can't change this if you don't own it, basically. Owning means if you're the server, then you own all the AI on your server, or if you're the player or the client, you own your player object. Okay, so let's go back over to the character manager now, and we're going to say using unity.netcode once again. And then we're going to change this to a network behavior. And again, since the player derives from this, it's going to get access to this network behavior. So let's then make a variable for our character network manager. Let's call that character network manager. And let's go down here on the awake and let's call that by saying character network manager equals get component character network manager, because we're going to add it to our player's prefab. And now the player will get that too because it is on the character manager. And then we're going to say if is owner inside the update functionality here, as in if you are the owner of this network object, we're going to say character network manager dot network position dot value is equal to the transform dot position of this game object. Else, as in if you're not the owner, so if this is not your player model, or if you're connecting to another host and this is their AI, then we're going to say the transform dot position of this game object is equal to vector3 dot smooth damp transform dot position comma character network dot position dot value. And we need a reference for a current velocity variable, so we can just make an empty vector3 here and call this network velocity. Make it public vector3 network velocity, or network position velocity to be very clear. And then we can pass that. So let's copy that, come over here now, back on the character manager. We can say character network manager dot and paste that there. And then we need a smooth time, so let's make a variable for that too. Let's make it about 0.1 seconds or 0.1 in value. Should be fine. So let's make a public float network position smooth time. Again, going to initialize mine at 0.1f. You don't want it too long because then the movement update will take too long to update. And you don't want it too short because then it looks too snappy. So I find 0.1 is a very good middle ground. Okay, and now this is going right across my screen, so I'm just going to make this a bit easier to read by spacing it out. And the reason why it's giving us an error is because we need to use the reference keyword here on the network position velocity. There we go. So I'm going to say if this character is being controlled from our side, then assign its network position to the position of our transform. And if the character is being controlled from elsewhere, so if you're a client connected to a host, then we want to take our version of the game object and assign its transformed position to whatever it is on the host's end or the other player's end. So imagine a player connects to your game. They have a game object in your game world, and they have one in their world. Whatever their position is in their world will be assigned to their game object in your world. Okay, so I want that to be very clear moving forward because I know a lot of people get confused by this. So I'm just going to give you a visual representation here just to show you. So I have a green player model on the screen right now and a red player model, okay? I want you to imagine that the green player model is you. You are controlling this character. The red player model is somebody else you're playing with. Now, in their game, they have their own player model too, and they have a representation of your player model in their game, much like you have a representation of their player model in your game. So, if you're the owner of your character, which you are, your player, then you're going to assign that network transform to whatever the position of your character is in your world. So basically, that network position becomes the position of your character model. Now, over on their end, they need to assign your game object on their end whatever your network positions variable is. So if you move forward, then your game object on their screen moves forward. And the same is true for them. So you need to assign their network position variable to their game object in your game. So when they move forward, then their game object in your world moves forward too. I hope that's clear. If it's not, please let me know because I need that to be clear moving forward because we're going to use the concept of owner a lot in this series. Okay, so let's make a new script. Let's call it Player Network Manager. And this is just going to derive from the Character Network Manager because in the future, the player is going to have a lot of its own network calls that AI will not need. So let's start by making our namespace as is per tradition. And then I'm going to make this derive from the Character Network Manager. I, of course, have deleted the start and update functionality. So these are all public, so they can be accessed from anywhere, including the class that accesses this data. So let's go to the player prefab now, and let's make, or rather add, the Player Network Manager to the player prefab object. And now let's go back over to the Player Input Manager, and let's make, or call rather, a function called onApplicationFocus. And this means, this thing is basically called whenever the game is focused or minimized or maximized. So I'm going to say if this input manager is enabled, and if we are focused, player controls.enable, else player controls.disable. What does this do? Well, it basically makes it so you can't read any more inputs when you minimize the game, so you can't move both projects at the same time if you have one focused up. This is really good for testing. It's completely necessary. And it's also just nice in general. But now if you open up two of your projects with the clone manager, you won't be able to control one while the other is focused. Now, we also have to go to the player manager and say if is owner, this is on update. If we're not the owner, return and don't run any logic. Otherwise, you will be able to control other people's game objects, and that is not good. So we only want to run the movement logic on this player manager if we are the owner of it, okay? So if we do not own this game object, we do not control or edit it in any way. Now we save that. Because when someone connects to your world, their game object will not be an owner. But when you connect to your own world, you will. And now as you can see, this is the other client I am able to move around and it updates on our other game. So you can see I'm moving around. This is on the second window and you can see it's updating on the main window here. And likewise, if I do the same and move my character around over here in the main window, it will update on the second window. So I can drag that over here like so, and you can see the player's position is now in front. Awesome, so now you guys have network synchronized position movement. So I'm just going to show you by dragging in the inspector here, and I can move it around using the Unity project itself, so you can see that it's not the controller moving two at once, it's actually moving independent of the other project. And now let's go back to the player locomotion manager and let's add rotation. So this is going to work similar in the network setup, but obviously rotation logic is a little different than movement logic. So we're going to rotate based on, again, the camera's facing direction, which is just how Elden Ring and Souls does it. We're going to start by making a vector3, and I'm going to call this target direction, as in the direction we want to rotate towards, equals vector3.0. And then we're going to say target direction is equal to, we're going to say player camera.instance, and this time we need to reference the player or the camera object itself and not the parent of the camera object. So let's go over now to the player camera, and let's make a public camera variable, call it camera object. And then we can go back over now to the player locomotion, and we can reference this camera object. So we can say camera object dot transform dot forward times our vertical movement, and then we are going to say our target's direction is equal to target direction plus our player camera dot instance dot camera object dot transform dot right times horizontal movement. All right, cool. So you do a few more things. So right below that now, actually, if you want to as well, you can make this a local variable here. So it kind of keeps in line with our conventions. So private vector3 target direction, I'm actually going to rename that so it's a lot more clear too, because target direction and move direction sound too similar. So I'm actually going to change it to target rotation direction, as in the direction we want to rotate towards, and apply that. And now back under handle rotation, under this, I'm going to say if target rotation direction is equal to vector3.0. So if we don't have one at all, then our target rotation direction will just equal to the way we're already facing. So that will be equal to transform.forward. So if you're not applying any rotation or any movement, then our target rotation is just where we're already facing. Then we're going to say quaternion. We're going to say turn rotation is equal to quaternion.look towards the target rotation direction. So whatever the direction is that we want to get, then we're going to want to rotate towards that. So we're going to use a rotation, which is a quaternion. And I'm going to rename that so it's even more clear. So actually I'm going to call it new rotation. So and then we're going to say our target rotation is a combination. So quaternion.slurp of where we're already rotated towards and where the new rotation direction is. So we take that new rotation and we move to that from our current rotation over a rotation speed variable times time.delta time. And we don't have a rotation speed variable yet, so let's make that. And it can be a float. And then we're going to say transform.rotation is equal to our target rotation, which again is a combination of where we're already facing and where we want to face over a time period of a rotation speed times time.delta time. So let's make our float for our rotation speed. So we can make it serializable field, so we can adjust that in the inspector. Float rotation speed is equal to, I'm just going to say 15. Again, this is a completely random number. You can play around with this. It will depend on your game, how you want it to feel. Rotation and movement greatly affect how the game feels. So let's say handle rotation here in handle all movement. So that gets called on our update functionality every frame, otherwise it won't work. And then we can come back over here to the player locomotion manager again and say target rotation direction dot normalize and target rotation direction dot y is equal to 0. Okay, and that should be working as intended. We still need to synchronize it on the network, however, so let's jump over to the character network manager. We can copy this network variable and paste it down here just so we can save ourselves some typing. And I'm going to change it from a network position to a network rotation in name, and the type will go from vector3 to quaternion. And then the starting value of it will go from a vector3 to a quaternion.identity. And then you also want to make sure you change the type on over here to from vector3 to quaternion. And again, the read permissions will be for everyone, and the write permissions will be only for the owner. So if you're not the owner of the object, you will not be able to change this variable. You will only be able to access its values. All right, that looks good. And again, read and write permissions are going to be the same here. Now let's jump back over to the character manager. And likewise, if we're the owner, we want to give the network our rotation value. So we can say character network manager dot network rotation dot value is equal to whatever our transform dot rotation is. And likewise, if we're not the owner, we have to change this object to represent the values of the owner. So we say transform dot rotation is equal to, and then we're going to do a quaternion dot slurp. And then we're going to make it from whatever our current rotation is to the new one over a time of our smooth time. So we don't have a smooth time variable right now, so we can make one. You can use the same one for movement if you want, but just in case you want them different for any reason of your own, then I'm going to make it its own variable. So let's go back over here now to the character network manager. I'm going to paste this below here, or copy and paste the network position smooth time and change it to network rotation smooth time. I'm going to keep that at 0.1 like so, and then I'm going to come back over here and just pass the network rotation smooth time. All right, that looks good. Excellent. And I'm just going to space it out here so it's easier to read, because if not, it's going all the way across my screen, and some people don't like that. So I'm going to make a comment here saying, again, this is the position, and then this one is the rotation, just so it's very clear if I want to read through this quickly where everything is in the future, because you will probably need to come back to these things at some point in time for sure. So let's save that. Let's go into the project here now and drag in the main camera variable so that's not null, we don't get an error. And then you should drag your prefab again to save it. And let's hit the play button and see what happens. So let that compile. There we go. Gonna press start, go in a new game, and boom, we do rotate towards the direction we're moving, which is as intended. Is exactly how it does work in Elden and Dark Souls. And now if I bring a second player into the game, you can see he's moving too, and it updates his rotation and his movement position for us on both ends. Excellent. So that is working as intended, guys. Now we have some movement and rotation, and it is synced via the network. And this is a good start to our character controllers. So on the next episode, we're going to set up our camera. And from there, we're going to start layering on more character actions, such as jumping and rolling and sprinting. But first, before we get to that too, we're going to animate our character's movement. So if you guys made it this far, be sure to drop a like and leave a comment. It does genuinely help out the series so much you have no idea. It really does. And a special thank you, as always, to my patrons. I appreciate each and every one of you. It's because of you guys I get to keep doing this, and I love doing this. So I will see you guys in the next episode when we get to our camera.